Welcome to this screencast. We are looking at performance of networks today. So typically, this could be your home. You've got a few PCs connected with an Ethernet cable straight into your home router. There's your television, a smart TV, or playing the Xbox, again, right next to the home router connected with an Ethernet cable. And you also have a wireless access point, part of that same box, where all your phones and tablets using Wi-Fi are connected to the router. After that, there's a cable connection into the street to the open reach of a Virgin box. And then that box will have a fiber optic connection to your internet service provider and eventually to the whole internet. Right. What could slow this network down? Well, first thing to consider is that you're not the only person in that street. So you've got plenty of other houses all connecting to that box down the street. And there's no reasons why those houses would not have as many devices and as many people connected to the internet doing their homework, watching a show, streaming some YouTube videos, all happening at the same time. So when you've got all these people trying to share that connection onto the internet, things can slow down, as you know. The first keyword for you to know in this chapter is bandwidth. Now the bandwidth is measured in bits per seconds. And that's going to be typically megabits or gigabits. Now, megabits per second, that's what's happening within your house typically. So the Wi-Fi signal, that's going to be, let's say, between 50 to 150 MBS. Cat5 Ethernet cable, 100. And if you've got a Cat6, that can be 1 gigabit or more. By the time you are talking about backbone, the professional one used by your internet service provider, those would be in the range of 10 to 100 megabits per second. But if you're sharing this bandwidth with 10 other houses in the street, as you know, things can slow down. So there's something here that you need to know for your GCSE, and that's a contention ratio, which is the bandwidth divided by the number of users. So bandwidth divided by number of users. So the more people are connected to that network, the slower it can be if everyone is a heavy user and if everyone is doing something at the same time. And that's when it becomes time to upgrade, change your contract with your internet service provider for one with a higher bandwidth. And in the case of businesses, it's not necessarily the bandwidth itself, the highest possible bandwidth that they'd be interested. They would pay extra money for a guaranteed bandwidth, just to make sure that it does not drop in case of heavy usage. So bandwidth connection ratio, now we need to talk about errors. So errors, as you know, a digital signal in theory looks like this, 0, 1, 0, 1, 0. However, in practice, these straight square shapes as an electrical signal, they don't actually exist. You've got a bit of noise, it's called, and then you don't have non-linear change like this, so it's going to be more rounded. And then let's say that at that moment in time, someone next door has switched on a very powerful radio transmitter and then is beaming a radio signal straight in the direction of your bedroom where you are connected with Wi-Fi, then that interference may degrade the signal to this point. Now, if the device is either switch or the computer that is processing this signal, essentially any electrical, any voltage above that limit would be read as a 1, below would be considered a 0. Then you got 0, 1, 0, and here you got a 0 instead of a 1, and there's an error appearing right there. So it could be because of electrical interference. It could also be because maybe the cable is too long. So an Ethernet cable that should be less than 100 meters. Well, at home, that's not really going to be an issue. But for example, in school, we can easily have cables that are longer than 100 meters between, I don't know, between the gym at the other end of the school and then where the IT technician's office and the server rooms are located. There's easily more than 100 meters there. So that's something to take into consideration, and then you're going to need another switch in between, or maybe a repeater, but some other box that is going to do something to help that signal do its job and carry on along the network. So boxes can introduce delay, and that's another word you need to know about. Let's make a bit of space. So latency, which means delay. You're sending something onto the internet and it needs to come back to you. Now, you know the internet is a network of networks, it's a mesh network, and there's going to be loads of routers on these nodes. Now, this is the server where you're accessing the website from, but right now there's something wrong going on here, so all the packets are going to be routed another way in order to get back to you. So far, so good. It's doing its job. It's performing as it should. But bear in mind that each one of these nodes, there's going to be a box, there's going to be a switch, there's going to be a router, there's going to be something that has to take some time, an infinitesimal small fraction of a second, but still some time in order to read the packet address and to make their decision in just process. I mean, these are routers, they're doing their job. But then suddenly we've got delay before getting back to this one and that one, and all these delays do add up. And if the packet is part of an email message, which is not going to be read instantly, we never notice those delays. However, if instead of sending data like an email, you're actually streaming the final of the World Cup in high definition, and there's something, this is happening just at the instant that when Messi is shooting at the goal. And because of this latency, you might actually miss, the customer might miss seeing on their high definition TV screen whether the goal is being scored or not. If it's entertainment, it causes frustration. If it's businesses, that could have more serious consequences. The last thing to mention, when I said you can upgrade your service with your ISP, you could buy a better WAP in order to move from the 2.4 gigahertz band to the 5 gigahertz, which has a capacity of being faster as long as the devices are closer together. Businesses will be not just interested in the maximum bandwidth, they will also be ready to pay for that bandwidth to be guaranteed not to drop under a certain level, because if it does, it's going to cause problem for those people who are actually working. I hope you find this interesting, and I look forward to reading your exam practice answers into our lesson.